General Cable, one company connecting the world. With manufacturing, research and development, sales representation and distribution worldwide, General Cable is a powerful partner with leading companies in the energy, industrial specialty, and communication markets throughout the world. Our cables bring power to homes and offices, countries and continents. They channel the power and signals that make equipment hum and engines run, from oil rigs and broadcast studios to cars and trains, to commercial buildings and factory floors. Our cables keep information flowing, facilitating a non-stop stream of words and images that transcend speed and geographic limits. General Cable is committed to providing quality products that service our customers' exacting requirements. Even with the more than 100,000 products we manufacture, the process of making wire and cable is similar, plant to plant, country to country. To start, all our wire and cable products begin with a copper, aluminum, or fiber optic conductor. Each is used for a specific application. This conductor is used to transmit electrical energy or signals. Most of our products use a copper conductor. The copper is extracted from the earth in an extensive process that turns rocky copper ore into pure copper. The coarse copper ore is mined and put through various processes that refine and purify it. The copper is crushed to bring the mineral down to a workable size. Next, the copper goes through a smelting process, which uses heat and chemical reactions to extract the copper from the ore. Pure copper is formed into copper cathode and rods, which are sold to traders or to wire and cable companies. Some General Cable plants have rod breakdown machines, where copper rod is reduced in size for the next step in the manufacturing process. Other General Cable plants purchase copper in the gauge size they need to begin their wire-making process. Aluminum, which also serves as a primary conductor in many of our wire and cable products, goes through a similar process of extraction and refinement and is drawn down from aluminum rod to the required gauge size for production. Optical fiber, another type of conductor, is a transparent material which can be the size of a human hair. Made from silica or glass, it transmits data efficiently with virtually no electromagnetic interference. Some General Cable communications plants purchase optical fiber to produce fiber optic cable for military and communications customers. So we start with a conductor, copper, aluminum, or fiber, drawn or stranded to the finished product's required diameter or gauge size. The conductor is then guided through an extruder where it is insulated with a compound or primary coat. Polyethylene, or PE, is one of the most common types of insulating compound. Other compounds are used for applications that require more flexibility or high performance. Plastic compound comes in a pellet form and is fed into an extruder. The extruder uses heat, shear, and compression to transform the compound into a flowing, malleable state to cover the conductor. While the insulated conductors may be identical in construction, different color coatings and banding can be used for identification purposes. Rubber compounding lines are capable of producing various types of rubber in many different colors. The process starts with various raw materials loaded into bins based on the compound recipe. The materials are then dropped into a large mixer. After a specified time, the mixture proceeds through a strainer. The strainer is used to convey the compound mixture to a forming or die head, where it is cut into strips. The strips travel along a conveyor system that cools the rubber before dropping the strips down into metal storage baskets. The rubber compound strips are fed into the extruder, which uses heat and compression to convert the rubber into a semi-liquid state. The tooling in the extruder head guides the conductor while the semi-liquid rubber is formed around it. The rubber-coated conductor enters a long tube that contains high-pressure steam and water or nitrogen. Here it is cured in the continuous vulcanization or CV process. After insulation, the wire moves through a water cooling trough to maintain its shape and thickness. The equipment in the primary extrusion lines includes monitoring devices that examine both physical integrity and electrical characteristics. Our operator-led process control, or OLPC culture, empowers our associates to interrupt production at any time to take corrective actions. This ensures no quality issues escape to the next process. These methods are employed in every major step of our manufacturing to provide the highest quality product in today's market. A single insulated conductor can be an end product, commonly referred to as a hookup wire. But individual insulated wires of different colors can be paired, twisted, or cabled together with fillers, shields, braids, and binders. They can then be jacketed, armored, and jacketed again before special footage markings and print legends are added. The finished cable is then packaged in boxes, on spools, or on reels. Now, let's take a closer look at a few different types of cables being manufactured. For copper communications cable, used in high-speed, high-bandwidth communications networks, we begin with two insulated wires of different colors paired together according to a color code system. They are paired to prevent signal interference between the conductors, commonly referred to as crosstalk. The color coding is significant for cable installers because it allows them to identify pairs and units of wire. Some cables have a small number of pairs, such as data communications products, which typically have 4, but these individual pairs can also be stranded or bunched together to form a single cable core containing 4,200 pair. This core is united together by a cabler, which assembles the stranded cores into one to produce telecommunications cable. Often, more binders, fillers, and tapes are applied during this process to cushion and secure the cables. A core wrap of polyester provides firm support and mechanical protection to the cable core and dielectric between the core and metal shields. Some receive a coated aluminum tape that blocks outside interference. A protective shield provides additional strength and shielding. On some designs, petroleum-based filling compounds prevent water from penetrating the cable. Depending on their use, some cables will need further outer protection. Shielding is a process that encloses the wires or cable for electrical or mechanical functions and reduces electromagnetic interference that could distort the integrity of the signal being transmitted. Some cable designed for buried applications is shielded specifically to prevent damage from gophers and other burrowing rodents who enjoy chewing on cable. In the case of portable cord, which is used wherever temporary power is needed, like on construction sites, in manufacturing facilities, or at entertainment venues, the individual conductors are a smaller gauge, which means bigger in physical size. The insulated conductor is taken up on metal reels before moving to the cabling operation. The portable cord conductors are typically black, white, green, and red, but can be produced in other colors. The color depends on the conductor count of the finished product, the country of use, or a customer requirement. The cabling process consists of twisting various colors of insulated conductors together. Depending on product design, fillers can be pulled into the twisting operation to fill gaps created between conductors. Various types of tape and cotton can be wrapped around the multi-conductor cable at this process, again depending on product design. Cablers can take on different forms and sizes depending on the product. Planetary, rigid bay, bow, and buncher cablers contain complex yet consistent rotation patterns. These patterns spin together foot after foot of quality-controlled cable. General cables, industrial, and specialty cables are used in a wide variety of markets. Traditional and renewable electrical power generation, oil, gas, and petrochemical industries, mining, industrial automation, automotive, marine, and transit, military, and OEM. All these cables use many of the same manufacturing processes, but general cable utilizes even more specialized techniques, such as continuous vulcanization, radiation, mold and moisture cure processing, and specialty shielding, braiding, and armoring. Braided shields are formed from a rotating mechanism that braids copper, aluminum, or bronze around the outside of the cable. Metal tapes, foil shields, and copper drain wires are a few of the other shields that can be used. Other cables may require heavy-duty armor, which provides the cable core with even more protection from extreme environments. CCW, or continuous corrugated welded cables, are specially designed and manufactured to operate in extremely hazardous locations. This product employs an aluminum metal tape which is formed, welded, and corrugated around the cable core for extra strength, making the cable impervious to gas, liquids, and vapors before the outer jacket is applied. General Cable also manufactures a complete line of energy cables, including low, medium, high, and extra high voltage power distribution and power transmission products for overhead, underground, or subsea applications. While much larger in scale, most of these cables proceed through a similar manufacturing process, with the exception of bare overhead aluminum conductors. These high and extra high voltage transmission cables are produced by drawing aluminum rod to the proper size or gauge and then stranding the conductor to the exacting specification of the overhead conductor's design. Jacketing is the final stage of production for most cables. This process provides outer protective elements to the finished cable core and may consist of plastic, rubber, or other compounds. Whether in an office or buried deep under the ocean waters, our cables perform in a number of environments, so the jacketing material and types of protectants can vary. All cable jackets receive a print legend, which can be applied with a surface print wheel, an inkjet printer, or an indent print wheel. This legend includes critical information such as product designation, agency approvals, and traceability, such as operator and date code. Some cables include our TrueMark sequential footage markings to advise the end user of the exact length of wire or cable on that particular reel or in a particular box. Along the way, the cables are tested in the required methods, including dielectric strength and capacitance. This ensures they meet industry standards and our customers' specifications. When the manufacturing process is complete, the finished product is spooled onto large reels or packaged on spools and in boxes. They are then sent to our regional distribution centers or direct to customers in virtually every region of the world. Powering cities and homes with renewable energy, transmitting vital information across the country, keeping our world moving at one synchronized beat. General Cable is one company connecting the world.